Hello students, now we will see the next example in method of sections. We have already solved few examples, now we will do another example in method of sections. Okay students, this is the next example that we have in method of sections. In this we can see that it says that we have to find out reactions at A and B, that is at this position. We have a hinge support at A and a roller support at B. Then it also says that find forces in the members EC, ED and DF. That is this member EC, ED and DF by using method of sections. Now, since we have to do the section method, we have to take a section in such a way that I'm cutting the three members with one single plane, if that is possible. If that is not possible, then we'll have to take at least two sections in that case. Now, if I take a section which is going from like this, that means I'm dividing this EC, ED and DF. Basically, I'm taking a cutting plane like this and I'm breaking this truss into two parts, the upper part and the lower part. Now once I do that, I'll get the members, that is EC, ED and DF. First, before doing that, we need to find out the reactions. How to find out the reactions? We know for the hinge support we have two reactions in the vertical direction and the horizontal direction, and one reaction for roller support, that is perpendicular to the surface, that is going vertically upwards. I'm assuming that. Now, the first step that I'm doing in method of finding out the reactions is I'm taking moment about point A. So if I take moment about point A, this 40 kilonewton force will be acting in the clockwise manner and the perpendicular distance will be 8 meters. The reaction at B, which is acting vertically upwards, it is acting vertically upwards, so that will create a anti-clockwise moment. The assumption that I have taken, the vertical reaction acting at B vertically upwards, is correct because I've got the answer as positive. Now, in this example, we don't have any horizontal force, so I can clearly say that the horizontal reaction at A will be 0. So I'll just write that equation over here. Then the next step will be to find out the forces in the vertical direction. The forces in the vertical direction is 40 kilonewton and the reaction forces in the vertical direction will be at VA and VB. Now, once I substitute the value for VB, I'm getting VA reaction as 120 kilonewtons negative. That means the assumption that the the reaction force acting upwards is wrong. I have to take it downwards. So I have shown the arrow over here. For this, it is acting vertically upwards. So the required part, find the reactions at A and B, that is done. Now the next step is to find out the forces in the members EC, ED and DF. For that, what I will be doing is I'll take a section like this. So in this way, I'm dividing the truss into two, that is one. Secondly, I'm cutting three members. three unknown forces. I'll try to cut the truss in such a way that I'm not cutting more than three members. Okay, so in this case I'm cutting three members, and that is the required case for me also. So I'll just mark this cutting plane as 1 1. Now after doing this, I'll consider any one part of the truss. You can consider the upper part or the lower part. Now I'll be considering the lower part, and then I'll try to find out the forces in the members, that is CE, DE and DF. So I'll just draw that part of the truss first. Now I've drawn this part of the truss. What I've assumed is that the force in the member CE is acting as tensile force. So that is the reason I have shown it acting outwards. Similarly, for DE and DF, I'm assuming it to be acting tensile. So I'll show it like this outside. Now, I'm not considering the other part of the truss. Now what I'll do is, I'll take moment about any one point. Could be C, D or E. Now, for example, if I take moment about this point, that is C. So what is going to happen is, I'll call this force as F1, F2, F3. Now what happens? If I take moment about C, the force F1 is passing through the moment center, and at the same time F3 is also passing through the moment center. So the moment of these two forces will be 0. I can find out the moment of the force F2 in that case. So I'll just write the equation for that. F2 is acting vertically upwards. So that means the moment that it is creating with respect to point C will be anti-clockwise. So I'll take it as positive. F2 into the perpendicular distance, that is 2. You can see this is the perpendicular distance given over here, that is 2 meters. Now, with respect to this point C, 120 kilonewton force is passing through the moment center. So I cannot take moment of that because the moment of that force will be 0. This force, that is the 160 kilonewton force, is acting vertically upwards. So now again, the moment of this force will be anti-clockwise. So I'll take it as positive. That's it. So now F2 I'm getting it as minus 160 kilonewtons. That means what? I have assumed the force in the member F2, that is the member DE, to be acting tensile. But since I'm getting the answer negative, that means my assumption that the force acting as tensile is wrong. The force is actually compressive. I have found the force in the member DE. Now next is DF and CE. What happens if I take moment about D? The force F3 and F2 will not create any moment because they are passing through the moment center. What about F1? F1, I'll have to resolve this force. So if I resolve this force, the horizontal component is not going to create any moment. The vertical component will. So I'll take a moment of that force about D. Now for that, I need to first find out the angles. Now in this case, I just need to find out this angle. If I call it as theta. Now this length CD happens to be 2 meters, and at the same time you can see that DE is also 2 meters. So this is like a 45, 45, 90 degree triangle. So I can say that this theta is 45 degrees. Now, with respect to D, F1 vertical component is going to create an anti-clockwise moment, whereas that would be a clockwise moment, whereas this force is going to create an anti-clockwise moment. So I'll write it accordingly. Now, since this is a clockwise moment, I'll write it with a negative sign. F1 sine 45 into 2. So I can find out the value for F1 as I've got the forces in the members CE and DE. Now all that remains is DF. For that I can take moment about E, because if I do that, that is this point over here. If I take moment about E, what happens? F1 and F2, they are not going to create any moment because they are passing through the moment center. F3 is going to create a moment, and that would be anti-clockwise. What about the force? That is 120 kilonewton. Even that is going to create an anti-clockwise moment. So I'll write an equation accordingly for that, and that would be about E. Now, I'm getting the value for F3 as 120 kilonewtons negative. That means the nature of the force in member, that is DF, that is this member, happens to be compressive. So accordingly, I have calculated the force in the required members. F1 is nothing but force in the member CE. F2 is nothing but force in the member DE, and F3 is in the member DF. So you can see that we have calculated the force in the required members by using method of sections. I hope that this sum is now understood by you all. Thank you.